That type of brown is the least stable. If you look over here, you can see barrier islands, and that basically shows the same thing in the Jersey Shore, these barrier islands here. These are actually mobile landscapes. However, in today's day and age, there's a lot of homes, condominiums, hotels, boardwalks, and all that sort of stuff there. Yes, it's vulnerable from storm damage, but that sand moves back and forth. When, 18,000 years ago, when the Ice Age was still near its peak, the continental shelf, if this is New Jersey, the continental shelf came out another 200 miles over here. And so these barrier islands were much further out. So the shore was lapping up over here. You had land mass over here, and so everything that you see here was actually 200 miles out. And over time, as sea level rose, these particular, because they're mostly made of sand and silt and small particles, they get moved back further inland over time. So the same thing is going to happen to any structures we put there. We build all sorts of, structures to try to hold that back, but we can't hold it back forever. We're dealing with climate change, sea level rise right now, for instance. These are just one example. The other thing, for instance, where do we live here? We're in Jersey City. Some of the things that are hazards to us right now that we have to think of. We're living up on a nice, right here, NJCU is kind of on a high area. This is called the Palisades Sill. So if you looked over here, you can see this is kind of a high zone right here, right? This is crystalline, this is volcanic rock from 200 million years ago. It's also resistant to erosion, rain, wind, and whatnot, so it sticks out. All the other sediment that's soft has eroded away. This particular high area, if you happen to live on Kennedy Boulevard, you're pretty safe from floods and rain and whatnot. But if you live down by Society Hill, that's right by 440, you're right by Newark Bay, anytime there's a storm event, you are subject to flooding. Same with the poor folks that buy these overpriced houses in Hoboken. They're on the other side of the Palisades Hill. On the cliff face side, you're also subject to all sorts of flooding and slope failure and things of that nature. So where you live plays a big part. This particular map was made by a student back in the 1990s, and it shows all the different topographical provinces of New Jersey. So you can also see here, this is all broken up in different areas, the types of rocks and terrain that encompass New Jersey. The 200 million year old rock that we're kind of sitting on here now, the rocks further to the west are over 1 billion years old, as soon as you cross the Ramapo Fault. And yes, we do have minor earthquakes in New Jersey. The Ramapo Fault is an old fault that is not active in the sense that of the earthquake faults that you're familiar with in California and the West Coast, where you have tectonic activity that is actively going on. We're on the trailing end, but we still have what's called slippage going on. So everything west of Route 287 will go up, and everything east is sliding down. And why is that happening? Go back to the Ice Age. 18,000 years ago, we had a mile of ice on top of New Jersey, up about until Perth Amboy, right down here. It depressed all the rock, with all that ice weighs millions of pounds. It actually, over time, depressed the rock down, down, down. And as that ice melted, it didn't rebound right away. It's been rebounding the entire time. So we have these earthquakes as the rocks try to recoup their original position from, 40,000 years ago, before the Ice Age, before the Wisconsin Ice Age glaciation. So there's all these different things that you can see in this library, museum, it's kind of both, that are discussion points. We have our local geology, which actually ties into climate change and past extinctions. You remember all those cars and buildings floating, just a month ago from Hurricane Ida? Think about that. What causes that? Energy, right? It takes energy to push anything, get something going from a stop. So the more energy we put into a system, the heavier objects we can move. The less energy something has, like a calm stream, you're moving small silts, clays, sand particles. You have enough energy to move that. These are giant boulders and cobbles that we pulled out of an outcrop just a little bit to the south of Frenchtown, New Jersey. And this occurred at a time period in the Stockton Formation when the Earth was going through some minor climate upheavals, where we had huge storm events moving boulders. That would be akin to moving cars down the street. So what I'm getting at is we can use, there's an old saying from James Hutton: the present is the key to the past is the key to the future. We've seen these things happen before. We can use the information that we gathered from old rock layers, which at first don't look like much of anything. But once you start to carbon date them, or radiometric date them, you start going back into the millions of years, you start to realize that there are patterns, and you look for patterns. And so there were mass extinctions in Earth's history. The most famous one, which one do you guys, what comes to your mind the first time you hear mass extinction? The dinosaurs, right? What killed the dinosaurs? Think about it. Close. It was a giant asteroid. Yeah, but I mean, it could be either, those two things. That was the major thing. There were two key pieces what killed the dinosaurs. Giant volcanic eruptions when India, I'm going to go bring my globe over here. Bear with me a second. India collided with the rest of Asia, the Indian subcontinent, creating the Himalayan mountains, right? But during that time, there were these massive volcanic eruptions. Not much unlike what we had here 200 million years ago, but on a larger scale. In New Jersey, we had these large volcanic eruptions too during the Triassic, Jurassic. And that's when the dinosaurs lived here. So we had, if you got on top of Rossi Hall, went up to the 5th floor, and you look to the west, and you start seeing these little hills in the distance, right? Those are giant lava flows from 203 to 185 million years, depending on which flow you're looking at. But that is when Pangea broke apart. North America and Africa were joined at this point here. And as the Atlantic Ocean began to open up, the mid-ocean ridge, which is over here now, was actually on the border of New Jersey and Morocco and Africa. So the cool thing about that is the volcanic rock that we have here in New Jersey is chemically identical to the rock in Morocco, Africa. The world's a small place. But it's separated by an entire ocean now, 200 million years ago. Where am I going with this, right? I've just got to get a point. Climate change is also part of environmental geology. You're looking at building structures. Is it a safe place to live, right? things that worked 30, 40, 50 years ago may not work now because the climate has changed. That extinction event was a 1-2 punch. Most people, you very good, you picked up on the comet or the asteroid. The second one that most people don't know about is the volcanic eruption. So basically, they were putting up tons of carbon dioxide into the atmosphere on this end of the globe here, which was already starting to cause extinction events. Then, this asteroid comes and hits in the Chicxulub crater over here, and right in the Yucatan Peninsula, and basically deals the death blow. About 75% of everything that lived during that time period died. Yes?
I have a question.
Yeah, shoot.
So, were dinosaurs microorganisms before they evolved?
Everything was a microorganism before they evolved. In fact, now that you mention that, I have something cool here. I'll bring it out in the middle so everyone can look at it. So, we all started out as simple cell creatures, right? And eventually we became, we evolved into more complex life. I'm not sure if I can find the right key. If not, I'll just show it to you, but I think this is it here. Good. Guys can pass these around. So when we moved from simple cell creatures, right? These are cyanobacteria, where they were simple cell organisms that were at the time living on a shallow sea environment right off the coast. They're still alive today in Shark Bay in Australia. Only place they're still alive now. And basically, these are simple blue-green algae. There's still different forms of them alive today, but the important thing about that, we have a lot to thank for these guys that you're holding in your hands right now. About 3.2-ish billion years ago, they started to alter our atmosphere to add oxygen for the first time. Because before that, there was no oxygen in our atmosphere. So because these things were alive at that point, they actually introduced, because photosynthesis, intake carbon dioxide and expel oxygen. It's the opposite. Plants do the opposite of what we do. We inhale oxygen and then exhale carbon dioxide. But these were the things to kick it off at one point. So we have a lot to thank for our ancient ancestors paving the way for more complex life to take hold. And it wasn't until the Cambrian explosion about 540 or so million years ago, where all of a sudden you get this explosion of this experiment of different types of life forms started to show up in Earth's past. And from that point we started to branch out into different types of microorganisms, plants, fish, things of that nature. So we went from plants that were, essentially simple celled creatures to more complex life at that point.